Hello, welcome to this video. Today we're going to look at this inequality. So we need to show that for all A, B, and C that are non-negative, that satisfy AB plus AC plus BC is equal to 1, the inequality A over A plus B over B plus C over C plus A is bigger than or equal than 2 over A plus B plus C plus A squared B plus B squared C plus C squared A over A plus B plus C. Okay, so let's begin. Oh, it seems, so these two have an obvious common denominator of A plus B plus C, so it might be useful to multiply by A plus B plus C on each side, because A plus B plus C is also symmetric across A and B and C. Which is good, and you'll soon see why. So first of all, let's write this as a cyclic sum. So this is the cyclic sum of A over A plus B, and if you don't know what a cyclic sum is, you basically have a cyclic sum of something, and then you're summing over, and then to get the next term, you're moving each one cyclically. So A goes to B, B goes to C, and if there was another C in here, it would go back around to A. So we would have B over B plus C. And then to move it again, we'll have C over C plus A, and that's where it ends, because we have 3 terms A and B and C. Okay, so that's the cyclic sum, and we're multiplying this sum by A plus B plus C. And this, we want to show, so this is a question mark, and we want to show that it's bigger than or equal to 2 plus the cyclic sum of A squared B. Now, because A plus B plus C is symmetric across A, B, and C, we can put it in the cyclic sum. I'll let you think about why we can do that, but we'll end up with cyclic sum of A times A plus B plus C over A plus B. And is that bigger than or equal to then 2 plus the cyclic sum of A squared B? Okay? So now I notice that we have A plus B over A plus B, which is 1 plus C over A plus B. This is this fraction, and so I can separate it like so. We have the cyclic sum of A plus AC over A plus B. And is that bigger than or equal than 2 plus the cyclic sum of A squared B? So now I'm going to move this to the other side, and we'll get the cyclic sum of AC over E plus B plus, now I'm already going to factor out A, and we'll end up with A times 1 minus AB. And is that bigger than or equal than 2? Now, notice 1 minus AB is exactly AC plus BC. And we can factor C out of it to get AC times A plus B. So this is AC times A plus B. And then, together with this, we'll factor out AC to get that this is. So, continue up here. The cyclic sum of AC times A plus B plus 1 over A plus B. And is that bigger than or equal to 2? Now we're going to show that this is indeed bigger than or equal to 2. So we have the cyclic sum of AC times A plus B plus 1 over A plus B. And here's what we're going to do. There's a pretty famous inequality called the AMGM inequality, and it states that basically the algebraic mean is always bigger than or equal than the geometric mean. If I write it down, it says that if you have x1 and x2 all the way up to xn that are all bigger than or equal than 0, then the following inequality holds. x1 plus x2 all the way out to plus xn over n is always bigger than or equal than the nth root of x1 times x2 times xn. Alright, and we're gonna use this because a and b are bigger than or equal to 0, a, b, and c are bigger than or equal to 0, a plus b and 1 over a plus b are both bigger than or equal to 0, meaning that we can use this inequality on it. We'll use n is equal to 2, x1 is a plus b, x2 is 1 over a plus b. And so this is going to be bigger than or equal than the cyclic sum of AC times. Now, the algebraic mean of these is the sum divided by 2, meaning that the sum is bigger than or equal than 2 times the square root of the product. And this is 2 times the square root of a plus b times 1 over a plus b. But notice, this is just equal to 1, and so we can get the 2. We can put the 2 out of the cyclic sum to get cyclic sum of AC. But we know this is equal to 1. This is precisely AC plus BA plus CB. And just a bit of rearranging, which doesn't change the sum, AB plus AC plus BC, which we know is equal to 1, so this is precisely equal to 2. Meaning that this is indeed bigger than or equal to 2, and then if we rewind our steps, so we go from here to here to here to here to here, and eventually to here, we proved our original inequality. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting content and things like this in the future. And finally, that's it.